Hello, you have already developed an application and you already know few of the basics. In this lecture, we will go deeply into some application fundamentals and we will cover some of the details that are needed to to master Android program. For this lecture, my reference is Android API guide, which is available at the given link. Let us look at Android applications once again. Your Android SDK tools compile your code along with any data and resource files into an APK file. An APK file is an Android package file with the suffix .apk, as you may have seen when you developed your application. This is in the same line as we have JAR for Java archive files or other archive files that you may have used earlier in your programming career. In Android, the one APK file that you create for your application contains all the contents of an Android app. That means all the resources that have been using, all the executable code, etc. APK is the file that any Android powered device will use to install the app, whether it is a tablet, whether it is a phone, whether it is a Google Glass, or whether it is a TV running Android. They all need an APK file. Android applications, once they are installed on a device, they live in their own security sandbox. This is a very good approach to make sure that one application does not destroy the whole system. Earlier in computing systems, you may have seen that if one application crashed, sometimes your system needed to be rebooted. In fact, you may experience the same thing with your PC from time to time. However, this situation is not desirable with a mobile phone, and especially with an open market where multiple applications are developed from various entities. So we cannot allow a situation in which crash by an application requires your phone to reboot. So the Android operating system uses an approach where it creates a sandbox for each application. A sandbox is like a virtual box in which your application runs, and if it crashes, the effect remains limited to the box. Android sandbox approach comes from the Java sandboxing techniques. The Android operating system itself is a multi-user Linux system, and each app acts as a different user. So as you may have seen in the multi-user system, each user is separated by another user, and each user is uniquely identified by the system. Similarly, in Android, each Android application is identified by a unique Linux user ID, and one application is separated from another application. And the system sets permission for all the files in an app so that only user ID assigned to that app can access them. These are some very sound operating system principles. You may have studied some of them while doing your operating system course. Android applies all of them to ensure that applications run in a limited environment where if an application crashes or wants to maliciously access data of other application, it is not allowed to impact the system. So each process in Android has its own virtual machine, and an app code runs in complete isolation from other apps. So by default, an application will run as its own Linux process. Android starts the process when any of the app's component needs to be executed. We will soon learn about different app components. And when the application stops, then the system shuts down the process, which is no longer needed. And the system recovers memory and other resources for other applications that are running. You may have studied some of these principles in the operating system. If not, then maybe you would like to revise your operating system concepts once again. Overall, Android is very similar to what a Linux operating system is, because that is the base on which Android is built upon. Android system implements what we call as the principle of least privilege. which means that an application will have just as much privilege as it needs. That is, that an application by default can access only the components that it requires to do its work and nothing more. So an app cannot access part of the system for which it is not given permission. This ensures that applications maliciously or non-maliciously do not affect the system at large. However, with the principles of least privilege, Android also allows mechanism for an application to share data with other apps and for an app to access system services. As you may imagine, this is very important and necessary to develop wonderful applications. For example, if you want to develop an application which accesses camera, that application must have some way to communicate with the camera app. So, an app can request permission to access device data whenever it wants. For example, users contact, SMS messages, the mountable storage, camera, Bluetooth, and more. Android requires that the user explicitly grants these permissions. You have already experienced it when you install an app and the app asks your permission. For example, if you install an app such as Paytm, which many of us use for paying, uh, which many of us use for paying bills, it requires access to your SMS messages because sometimes it wants to access SMS to authenticate itself and to validate its user. Similarly, there are other applications which require access to your contact list or to your camera or to your GPS or any other system resource, and every time an explicit permission from the user is required at the time of the installation. It is also possible in Android that two apps share the same Linux user ID. Because they can share the same Linux user ID, they can access each other's file. We will learn more about it in later weeks when we will learn more about it in later weeks once we develop towards advanced programming development. We will learn more about it in later weeks once we have developed our basic understanding and would like to develop more advanced applications. Now, to conserve system resources, app with same user ID can also arrange to run in same Linux process and share the same VM. But these apps must then also be signed with the same certificates. Don't worry about these details, we will be discussing them much more in detail. Don't worry about these details, we will be discussing them in later chapters. Don't worry about details. Don't worry about these details, we will be discussing them in more detail later. Now, let us look at app component. An Android applications the now let us look at app components. There are essentially four building blocks for any Android application. An Android application may have either one of them or two of them or three of them or all four of them. You have already experienced one of it. It's called activities. The other building blocks are services, content providers, and background receivers. Each of these components define a point through which the system can enter your application. Activity. As you have already seen, activity represents a single screen with a user interface, and an activity is implemented as a subclass of activity class. For example, if you have an email app, then there may be an activity that shows you the list of new emails, another activity to compose an email, and another activity for reading emails. So a single email app may consist of three activities. Currently in our Math Quiz application, we are only using one activity, but very soon we will move to implement more activities into the same applications. And although the activities work together, And although the activities work together to provide a cohesive experience to the user, they are independent of others. And as such, a different application can start any one of the activities if the parent applications allow it. And as such, a different application can start any one of the activity of another application as long as it is provided by the permissions. For example, a camera app can start the activity in the email app that composes new email in order for the user to share a picture. You may have experienced some of these when you open your WhatsApp or your Facebook application and you want to share something. An activity is implemented as a subclass of activity, and as you have already developed one activity in your program, we will be learning more about activities later on. The another building block is what is called a service. A service is a component that runs in the background to perform long-running operations or to perform work for remote processes. A service does not provide a user interface. Let us take some examples of services. One of the example could be a service that downloads data in the background. As you may imagine, downloading data in the background does not really require a user interface. Another example is a service that plays music in the background while the user is in a different app. So there could be various services that you can implement which work in the background. Another component, such as an activity, can start a service and let it run or bind it to others in order to interact with it. A service is implemented as a subclass of service. Let's look at the another app component. Content providers. A content provider manages a shared set of app data, as you can imagine from the name that it is providing some content. Now you can store this data in the file system an SQLite database, on the web, or any other persistent storage location your app can access. And through the content provider, other apps can query or even modify the data as long as the content provider allows it. You may also use content providers for reading and writing data that is private to your app and not shared. That is, a content provider can be used both for saving private data and also the data that you may wish to share with other apps. A content provider is implemented as a subclass of content provider, and it must implement a standard set of APIs that enable other apps to perform transactions. The fourth component is the broadcast receiver. Broadcast receiver is a component that responds to system-wide broadcast announcements. For example, a broadcast announcing that the screen has turned off or that the battery is now low. Sometimes you may have seen a notification that says battery is low 15% or battery is low 3%. Please plug in your phone. So these are the kind of broadcasts that we are talking about here. An app can also initiate broadcasts. So for example, an app may want to broadcast that it has downloaded the data that you wanted to download. So broadcast receivers may create a status bar notification. They do not really need a screen, but status bar notification is very common for broadcast receivers to implement so that they can alert the user when the corresponding broadcast event has occurred. A broadcast receiver is just a gateway to other components and is intended to do a minimal amount of work. A broadcast receiver is implemented as a subclass of broadcast receiver, and each broadcast is delivered as an intent. So far we have not covered intent in our lectures. Neither our application has any intent built in. As of now, you can understand intent as only a message object. That is, it is a message which is delivered to get some action done. We will learn more about intent in our later classes. Now, the beauty of Android lies in that any app can start another app's component. Just as I gave the previous example, your app may want to use the camera app to capture a photo. And when the system starts a component, it starts the process for that app if it is not running and instantiates the classes needed for the component. If your app starts an activity in another app, then that activity runs in the process that belongs to another app and not in your app's process. Let's go through these points again. Suppose you want to run your application and your application has a component, let's say activity. The moment you want to start this activity, there will be a corresponding process for your app. And all the classes needed for this component activity will be instantiated. Now this activity wants to initiate another activity in another app. Now the new activity will run in the process that belongs to the another app and not your process, because essentially you are running an activity of another application. Due to this feature, Android apps do not have a single entry point, because as you may imagine, an app's component can be instantiated by any other app. So there is not a single entry point. A camera app may have many components, and these components may be initiated in a different order by different apps. And this is also the reason why there is no main function in an Android program. Some of you have already noticed that they could not find a main function. Others may have not looked closely, but now you can look for this and you will not find a main function. Because a main function essentially implies that that's where the execution starts. But this is not true for Android applications. An Android application may start whenever any component is initialized. As told earlier, the system runs each app in a separate process with permissions that restricts access to other apps. So an app cannot directly activate a component from another app, but what it does is that it makes a request to the system. And when it makes a request to the system activates that component for the app. Let us learn a little bit more about intent and activating components. Activity, services, and broadcast receivers. These three components are activated by an asynchronous message which we call an intent. Like I told you earlier, intent is more like a message object. For activity and services, an intent defines the action to perform, while for broadcast receivers, the intent defines the announcement being broadcast. For the fourth component, the content provider, it is not activated by the intents. It is activated when targeted by a request from a content resolver. We will read more about it in later lectures. So an intent binds individual components to each other at runtime, whether the components belongs to your app or another. So these are like the messengers which goes from one component to another component to another component. You create an intent in your program with an intent object. An intent object defines a message to activate either a specific component or a specific type of component. In Android, we can define both implicit and explicit intents. Do not worry too much We will soon be implementing intents in our program, and then you can come back to these lectures and make more sense of what we have learned. And there will also be more details in the later chapters about intents. Now the last topic of this lecture, the manifest file. You have already seen the manifest file in your project. A manifest file declares all the components of the app. It is used by the Android system to know what components exist in an app. A manifest file identifies the user permissions that app requires. For example, access to internet, or to use users' content, or to use users' SMS services, camera app, GPS, etc. etc. The manifest file also declares the minimum API level required by the app. And it also declares hardware and software features used or required by the app. It also declares API libraries that the app needs to be linked against, such as if you are using Google Maps library. A very good detailed instructions of the manifest file is available at this link. Let's click it and try to see. So you can see this is the same link which I had given. It defines app manifest. As you can see that this is the same link that I have given. If you click on it, this page will open. Let's go through it to understand the manifest file. So every Android application must have a manifest file. Every Android application must have a manifest file, and that manifest file must be named Android manifest.xml. This name is precise, that is, you cannot change it. The manifest file presents all the essential information about your application that the Android system requires. It names the Java package, describes the component of the application, determines which processes will host application component, declares permissions, etc. etc. Now let us look at the structure of the manifest file. As you can see that the manifest file starts from the manifest tag, and then it goes into user permissions, user SDK, configuration, features, etc. etc. and then it comes to application. Let us try to see what these fields are. I will also open our program that we have developed. So this is our manifest file as it is given here. We don't have anything on top. We don't have anything on top except the package given. And then we have the application. Inside the application, some fields are given. We will try to understand them. But let's go back to the original structure of the manifest file. A manifest file starts with following fields: user permissions, SDK, configuration, support screen, etc. Then it comes to application components, activity, services, broadcast receivers, and content providers. If you click on any of these fields, you will get the detailed values of them. So in your free time, you may want to click on it and find out what it means. For example, user SDK, it must be min SDK version, target SDK, maximum SDK version. We have already seen some of these earlier when we were setting a project. Whatever settings you did in your project come in your manifest file, and your manifest file is used by Android to understand your application requirements better. That is it for today's lecture. In this lecture, we went through some more fundamental knowledge of Android applications, and we also went through the manifest file, and you also came to know that why Android applications do not have a main function. For this lecture, I am using the reference of Android API guides which are available on developer.android.com. Thank you.